MPO cables are high-density fiber optics with 12, 24, or 48 fibers, providing fast, reliable connections for data centers, telecom networks, and similar environments. MPO cables have male, female connectors on both ends, with 8 to 144 fiber counts available. Their single-sheath design is ideal for connecting fiber patch panels and switches in a cabinet. Advantage is high bandwidth. Offer higher bandwidth by carrying multiple data channels on a single cable. Scalability. Enable easy upgrades to 40G, 100G, or 400G networks without replacing the infrastructure. Reduce cable clutter. Simplify management by combining multiple fibers into a single connector. MPO connectivity. MPO cables transmit data in parallel, splitting signals across multiple fibers, providing much higher bandwidth than single fiber systems. What is the method of data transmission? MPO cables transmit multiple data streams simultaneously, with each fiber carrying a separate data lane. For example, in a 100G Ethernet system, 12 fibers can each transmit 10 gigabits per second, totaling 100 gigabit per second. High-speed transceivers. Transceivers convert electrical data into optical signals for transmission over MPO cables, enabling high-speed data transfer over long distances. Single-mode MPO cables. Single-mode fibers use very thin cores 8 to 10 microns for long-distance transmission up to 40 kilometers or more with minimal signal loss. Multi-mode MPO cables. Multi-mode fibers use thicker cores 50 to 100 microns for shorter distances up to 300 meters. They allow light to travel along multiple paths, suitable for shorter range applications like within data centers. Conclusion: MPO cables enable parallel data transmission across multiple fibers in a single connector, providing high bandwidth, space-efficient connections. They reduce cable clutter, support scalability, and are essential for high-speed optical networks in data centers.